Be careful, Lund. Save yourself. We're drowning.
Quick, check this out. Over 5,000 ships have been lost near this coastline. Pirate galleons, Civil War ironclads, even modern boats. They've all gone whoosh under the waves. This is a story about the famous graveyard of the Atlantic. For sailors, one of the most dangerous places on the planet. This place is called the Outer Banks, located off the coast of North Carolina. It consists of long, narrow islands that look like nature's speed bumps between the Atlantic Ocean and the mainland. From the air, they stretch out like lazy strips of tan ribbon floating on blue water. You'd never guess anything sinister happened here. It just looks like miles and miles of soft beaches, ready for bonfires and beach parties. Except these islands are, for lack of better words, restless. Geologists sometimes call them barrier islands, but the word barrier makes them sound solid and dependable. Truth is, they're more like runaway sand piles, always rearranging themselves whenever the sea decides to push and pull. Even Google Maps can barely keep up. Islands shift, they slide, they crack in half and come back together again. A storm doesn't just mess up your beach castle, it might literally erase the entire beach. In 1846, a hurricane punched straight through one of these islands and created an entirely new inlet that's been shifting ever since. One other cool example is from 2003, when Hurricane Isabel remodeled the landscape with a brand new 1,700-foot wide inlet. It cut a section of the island completely. People were stuck on the wrong side. The only way in or out was by boat or airlift because the road was completely underwater. Yes, an entire highway was washed off and submerged. There had to be at least one local who was like, "Hey, cool! I always wanted to live on an island inside another island." More recently, in 2017, a brand new island nicknamed Shelly Island suddenly appeared off Cape Point. People were walking on it, taking selfies, posting TikToks. Less than a year later, gone. Vanished back into the waves like some kind of magic trick. That's what makes this place so unpredictable. It's like the land is on loan from the sea, and the sea always wants it back. But why does this happen? Let's say you build a sandcastle right where the waves keep hitting. Not up on the dry sand, but right where the water's coming in and out. Every time you shape it, the water swooshes in and steals a little piece of it. Now imagine that instead of one castle, you're trying to build a whole island like that. That's basically what the Outer Banks do every single day. That's because these islands are made of sand, not rock. Just soft, annoying, squishy sand. And the ocean is constantly poking at them, stealing a bit here, piling up more over there, and rearranging everything like it's playing a giant game of beach Tetris. Now, add some powerful forces underneath the water. Here, the Gulf sends up a blast of warm water. The Arctic sends down icy waves, and they collide into a swirling milkshake that scrambles sandbars all over the place. This is what makes it so dangerous for ships. Imagine wearing a pirate hat and navigating your Black Pearl through something so unpredictable. Or even a modern cargo ship. The water's shallow, but it doesn't look shallow. The sandbars are underwater, but they move around. The currents are pulling your ship in every direction except the one you want. And even if you are a master helmsman, you still have to deal with fog so thick you can't see your own mast, followed by storms that smack ships around like toys. As you can see, it's not one single trap, it's the whole ocean acting like it's out to get you. And for thousands of unlucky ships, it did. This stretch of water has always been a magnet for pirates, scavengers, and anyone with an eye for opportunity. You probably heard about Blackbeard, the legendary pirate who plagued the American coastline in the early 1700s. His flagship, the Queen Anne's Revenge, sank near Beaufort Inlet in 1718. Stories say Blackbeard even blockaded the entire port of Charleston before his ship finally went down. And yep, it's still there. Divers found the wreck in 1996, and they're still pulling up cannons, gold dust, medical tools, and all kinds of 18th century pirate loot. Over the years, locals made a living salvaging whatever the ocean tossed onto their shores. Timber, tools, cargo. If it washed up, it got used. The now abandoned village of Wash Woods, located near the Virginia border, was famously constructed by survivors of a shipwreck. They used cypress planks from a ship that had washed ashore during a storm in 1889 to build the village along the Virginia beach. They built homes, a church, and even a school out of wreck wood. Nice way of recycling. And then there's Nag's Head, which sounds like the name of a pirate bar, but actually comes with one of the coolest legends on the coast. According to local folklore, centuries ago, wreckers in the area came up with a sneaky trick. They'd tie lanterns to the necks of old horses or nags and walk them along the dunes at night. From far out at sea, that bobbing light looked like another ship sailing safely near the shore. Captains would follow it thinking they were in safe water, only to slam straight into a hidden sandbar. Now, is that legend true? Probably not. Historians haven't found any solid evidence that it ever happened. However, when the ocean is sinking ships full of goodies near your shores, becoming a shipwreck scavenger starts to sound like a pretty solid career move. But even with modern technology, ships are still getting wrecked. In 2012, the tall ship Bounty sank off the coast during Hurricane Sandy. It was a modern tragedy with a very old pattern. A ship meets a storm, and the storm wins. The boat was actually famous. It was a Hollywood-built replica of the 18th century Royal Navy ship with the same name, created for the movie Mutiny on the Bounty. The original met its fate in 1789, when it was burned after the infamous mutiny. Then in 2020, the Ocean Pursuit, a commercial fishing vessel, ran aground near Bodie Island. And it's still there, slowly being swallowed by sand and surf. There are many similar examples. Whether you're a pirate, a U-boat commander, or just trying to catch some tuna, the graveyard of the Atlantic doesn't care. If you sail around here, you might just become part of the collection. And get this, we haven't even found everything yet. A lot of shipwrecks in the Outer Banks are still buried under sand dunes or lurking underwater. Some of them only show up when storms change things around, kind of like the ocean lifting a little peek of its curtain. Archaeologists keep finding new wrecks, even decades or centuries after those ships went missing. Who knows what else is hiding down there? It could be a real pirate treasure. Maybe some cannons or a whole ship lost to time. Not to mention that it's not just about money or gold coins. Every wreck is a time capsule, sealing away stories of people, technology, and history. To divers and archaeologists, that's a kind of treasure you can't put a price on. But if it's so dangerous, why do they still use these ocean routes? Even with the risks, ships still pass near the Outer Banks, since it's right in the way of a major shipping route. The Atlantic coast of the US is super busy, and the Outer Banks is positioned between northern ports and southern ports. If you're transporting goods, it's tough to find a shortcut without wasting time and fuel. Plus, modern technology does help. I guess the moral of the story is, get a better ship with GPS and sonars. The graveyard of the Atlantic is still open for business. Ships keep sailing through, storms keep rolling in. And the sea? The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, Let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
Now, you might want to book your dream vacation to Miami Beach as soon as you can, because this whole area might be underwater in the next 75 years. But it's not just Florida. Parts of Louisiana, California, and Washington are also expected to be among the first American states affected by sea level rise. If you live in the United States, you can check for yourself whether your address is on the list of cities that will disappear. Just search for Sea Level Rise Viewer on Google. That will take you to a tool created by the National Oceanic and Atmospheric Administration. And it helps us visualize what coastal flooding might look like in the future. Now, you see that dark area in blue? Those are the sinking cities of the U.S. And by that, I mean cities that could be submerged by 2100. That's in the worst-case scenario, if ocean levels were to rise by as much as 10 feet. Hopefully, it won't come to that. As you probably know by now, sea levels are going up because the Earth is getting warmer. When the planet heats up, ice at the North and South poles melts, and all that extra water flows into the oceans. Plus, warmer water expands and takes up more space. So, between the melting ice and the expanding oceans, sea levels slowly rise over time, and that means more flooding and even the possibility of some cities ending up underwater. Right now, statistics show that sea levels are expected to rise by around 6 feet by the year 2100. The problem is that this could cause major coastal flooding, and not just during storms or heavy rains. Even on clear days, some areas could end up underwater. And that brings us to a question. How do we actually know how high ocean waters are? These days, experts can measure sea level with incredible accuracy, thanks to satellite altimeters. That's basically a special type of radar that measures how high something is. It figures out the height of the ocean by timing how long it takes for a radar pulse to travel from the satellite down to the surface of the sea and then bounce back. When scientists combine that data with the satellite's exact location, they can map even the tiniest changes in sea level all over the world. Right now, coastal flooding predictions are showing us something serious. The rate of global sea level rise has doubled over the past 3 decades, and there are plenty of tools online that help us to visualize just how big this problem could become in the future. The Sea Level Rise Viewer I mentioned earlier focuses on areas within the United States. But if you don't live there, you can still check if your address might be in danger. Just look up the interactive map from Climate Central. If you set the water level to 10 feet above the high tide line, you'll see that a lot of countries could be seriously affected. Let's take a look at South America. In Argentina, for example, rising waters could flood many parts of Buenos Aires province. Head over to Brazil, and you'll see that a lot of cities, including Rio de Janeiro, would be affected. We might have to say goodbye to that iconic wave-patterned sidewalk along Copacabana Beach, and both of the city's airports would be flooded too. Things don't look much better in Europe. Major cities like Lisbon in Portugal, Valencia in Spain, and Rome in Italy could end up partly underwater. Honestly, the worst situation in Europe is probably in the Netherlands. Right now, about a quarter of the country is literally below sea level, and nearly half of it sits just 3 feet above. So if sea levels rise, they are facing some serious risks. This entire red zone, which includes cities like Amsterdam and Rotterdam, would be below the surface if the ocean rose by 10 feet. Fortunately, the Netherlands is probably the country with the most experience in fighting back against the sea. For years, they have tackled the threat with massive infrastructure, things like giant canals, windmills, and dikes, all designed to manage the water. And thanks to their efforts, the Dutch have reclaimed about 20% of their land from the sea. That's right, they're actually expanding. Unfortunately, some countries are at much higher risk than others. According to estimates, about 5 of them are in serious danger of disappearing in the near future. First up is Fiji, a tropical paradise loved by tourists. This nation is in a tough spot because of its low-lying landscape. There, extreme warming could cause sea levels to rise by as much as 6 feet by the year 2100. It doesn't help the fact that Fiji sits right in the middle of the Pacific Ocean, where massive storms can quickly turn things into chaos. That means people there need to brace themselves for more frequent flooding, and they're already taking action. To protect against coastal erosion, some communities are lining the seashore with old tires to keep sand from washing away in stronger waves. Others are planting mangroves across the coast. These trees can reduce the height of waves hitting the shore by an average of 31%. Plus, they help cut down wind speeds, which really matters during cyclones. Next on the red list is Vanuatu. This chain of islands, located between Australia and Fiji, could be underwater sooner than we think, and they're already making changes. Vanuatu was one of the first Pacific nations to relocate an entire community to safer ground. Back in 2005, people living in vulnerable areas on the North Island of Tegua moved to higher land. With temperatures continuing to rise, they're bracing for even more intense tropical cyclones. That means heavier rainfall, more flooding, and a much higher risk to both homes and infrastructure. The Marshall Islands are also facing a serious risk. This country is home to around 39,000 people and lives on the opposite side of the world from the United Kingdom. It's an extremely low-lying island nation built on what's basically a coral reef. According to NASA, sea levels there have risen by almost 4 inches over the past 30 years, and they could rise by about 7.5 inches over the next 30. And that's no small thing. If nothing is done, the islands could face more than 100 days of flooding every year by the end of the century. People over there are afraid of losing their homes. Studies also show that up to 40% of the buildings in the capital city, Majuro, could end up underwater in the future. But this country isn't ready to give up, and they're reinforcing the infrastructure. The Solomon Islands are also being slowly swallowed by the sea. This region has been experiencing sea level rise at nearly 3 times the global average. Over the years, satellite images have shown that 5 vegetated reef islands have already vanished beneath the waves. On the bright side, the people there are working hard to protect their homes. They're building stone walls along the coast and planting mangroves to hold back the water. But the worst case might be Tuvalu, as it could become the first country to turn completely uninhabitable because of rising seas. This island chain, located about halfway between Australia and Hawaii, sits only about 9 feet above sea level. And in its narrowest spot, in a place called Fungafale, the land is just about 65 feet wide. You can see how vulnerable the situation is, right? I mean, even before the higher tides arrive, the country's limited farmland could be affected by salt water. These islands are a powerful example of resilience, and a reminder that sinking cities don't have to mean disappearing ones. While the challenges are real, the global response to sea level rise is growing stronger every day. Around the world, communities are adapting, innovating, and coming together to tackle the threat of rising water.
This is Thwaites Glacier, located in West Antarctica. It's also known as the Doomsday Glacier, because if it collapses, it's game over for coastal cities. While summers are getting hotter, the glacier is being eaten from below by warm currents. It looks bad, but scientists have a plan. They consider building a gigantic sea curtain, an underwater 50-mile-long wall chained to the bottom of the dark ocean floor of Antarctica. Is this even possible, and will it work? Let's find out. The Doomsday Glacier is roughly the size of Florida. It's a massive river of ice draining a huge chunk of West Antarctica into the ocean. It currently loses more than 50 billion tons of ice every year. That equals 20 million Olympic swimming pools of water being pumped into the global sea. This single glacier causes about 4% of global sea level rise each year. This number might sound very, very small, but that melt rate is accelerating. If Thwaites crumbles completely, it holds enough water to push the global ocean up by a full 2 feet. It would permanently erase beaches and turn daily high tides into neighborhood floods. That's 2 feet added permanently to every high tide, every storm surge, every coastal flood, everywhere. But the real danger isn't the 2 feet. Thwaites helps hold back enormous volumes of inland ice. If it goes away, much more of West Antarctica can follow, leading to the sea levels rising far more than just 2 feet. To prevent this, engineers modeled the most ambitious underwater megastructure in human history. Satellites can see the surface, but the real problem is below the glacier. Near Thwaites, there's warm water. Even water that's only a few degrees above freezing can melt ice if it keeps flowing. It's like holding an ice cube under a running faucet. The water doesn't need to be hot, it just needs to keep coming. Over time, water thins out the glacier from beneath and weakens the brace holding it back. Once that brace gets weaker, the ice loses its grip on the seafloor and slides into the deep ocean much faster. That's where the sea curtain idea comes in. The goal is to keep that warm, deep water from reaching the underside of the ice shelf in the first place. Something like a long, flexible underwater barrier that rises up from the seafloor and blocks the warmest water from sneaking underneath. It doesn't fix the glacier forever, it just buys time by cutting off some of the ocean heat. So, how do you build something like that? Don't imagine a massive concrete dam. It looks more like a long underwater shower curtain, stretching 50 miles and 500 feet tall. Along that line, anchors are planted into the seafloor like underwater tent stakes, and overlapping flexible panels are attached, so they can bend instead of snap. Warm water is saltier, which makes it heavier, so it sinks and slides along the bottom, creeping under the ice shelf from below. The curtain rises high enough to block that deep layer. When the warm water reaches it, it has to move upward and mix with colder water, which cools it down before it can melt the ice as effectively. Human construction crews cannot dive 3,000 feet. Pressure is unbearable and even sunlight doesn't care about going that deep. Building the curtain requires a fleet of autonomous underwater drones. These robots will use sonar to map the terrain before drilling massive steel anchors directly into the bedrock. Once the curtain is up, they'll patrol the line looking for rips. Living at the bottom of the world would need some serious setups. Those robots can't just swim up to the surface to change batteries. The freezing ocean above would lock them into place. To make this work, engineers might have to set up a whole underwater base camp. Drones would probably have to dock at huge charging stations on the ocean floor just to recharge for their next mission. The ocean itself will work against this project. The strong currents and drifting icebergs would always stress the curtain. In those conditions, the concrete wall would break. That's why they're looking at using flexible fibers. It bends and wobbles with the flow. If a random current makes a little tear, the current just flaps until a robot shows up to fix it. Engineers also have to worry about rogue icebergs. When massive chunks of the glacier break off, they rarely float away cleanly on the surface. Getting the gear to this part of the world is already an epic quest. Antarctica doesn't have a Home Depot yet. So bolts, fiber, and spare drones have to arrive on cargo ships from thousands of miles away. The team only gets a brief summer window to work before the ocean surface freezes completely solid. But even if engineers could achieve all of this, there's one other roadblock to consider before putting up a roadblock in the water. The Southern Ocean carries nutrients for tiny floating plants called phytoplankton. When plankton blooms, it feeds krill. Krill feeds fish and squid, and they are food for lovely penguins, seals, seabirds, and even whales. What if the current accidentally sends that heat straight into a different glacier, or blocks food from reaching local whales? You cannot exactly test a project this massive in a local swimming pool. Building this underwater marvel is only step one. It requires a permanent mechanical workforce living down there for decades to swap out cables. Experts estimate that the project could cost around $80 billion. That is literally space program money. The hardest part of the entire project might actually be getting coastal countries to split the massive bill. The most likely funding model would be a coalition of coastal countries because they don't want their cities turned into aquariums. But even a perfect 50-mile underwater curtain cannot completely stop the ocean from rising. It only hits the brakes on one specific problem. The ocean actually rises in a few different ways all at once. Surprisingly, not all of them involve melting ice. When water gets warmer, it actually expands. The molecules in the water get super active and spread out more. That means the same amount of water now takes up more space. And because the ocean has nowhere else to go, that extra volume pushes the surface higher. The planet is doing exactly this, but on a much bigger scale. Then, we have Greenland. It's way bigger than glaciers like the Doomsday Thwaites. It's a sheet of ice the size of an entire country. The Greenland ice sheet has been shrinking for decades, with net ice loss every year for nearly 30 years straight. If that block melted completely, global sea levels would rise by 23 feet. That can put a two-story house completely underwater. Mountain glaciers also add to the global sea level. Alaska alone has thousands of these, let alone what is scattered around the world. These mountaintops act like giant frozen water towers. They're slowly dripping away under the sun and feeding into the same global sea. Combine all that extra water with a storm surge and the results get very real. A storm surge acts like a giant shovel, pushing the ocean inland for a few hours. If the starting water level is even 1 inch higher, that surge pushes significantly further down your local streets. It easily overtops concrete seawalls that used to do the job perfectly. This can lead to a rare neighborhood flood suddenly becoming a yearly headache. None of this means you should cancel a trip to Miami, not in this century. Sea level rise is slow, and even a Thwaites collapse would likely play out across decades. But it's still moving in the wrong direction, which is why scientists are hunting for ways to slow the clock. And honestly, if this curtain ever gets built, Watching robots anchor it to the Antarctic seafloor would be one of the strangest engineering live streams in history. Greenland, as we know it, is on borrowed time. By 2100, almost nothing will remain. We shouldn't treat the white mass on a map as permanent. It's just an illusion. Yes, it looks solid, frozen in time, but in fact, it's rapidly vanishing. The latest climate models are more than alarming. They suggest that under high warming scenarios, the Greenland ice sheet could lose more than half of its volume by the end of this century. For scientists, it may be just a line on a graph. But what about people living on the island? Their home is being erased in real time. If this ice melts entirely, global sea levels would rise by over 7 meters, reshaping coastlines around the world. It will be a pure geological nightmare, but there's also a quieter shift happening right here, one that satellites don't always catch. Let's stick to the Greenland Society and zoom in on these tiny coastal settlements. Needless to say, life here isn't only about the cold, it's also unforgiving. To picture it better, fresh vegetables cost a fortune. Internet is a luxury, and most of the time it's basically dark. Results are easy to imagine as those harsh conditions take a lot. Greenland currently struggles with a severe mental health crisis and a heartbreaking situation connected to the deep emotional weight of isolation. For the younger generation, the reality offers only one direction: away from the island. They leave for Denmark to study or find work, and once they experience a life where groceries are cheap and the sun shines in winter, they rarely come back. Hard demographic decline, small villages are slowly turning into ghost towns as the elderly pass on and the youth simply never return. Within 60 to 70 years, Greenland will be in a truly tragic, ironic situation. Picture this. As the ice retreats, it's exposing massive deposits of rare earth minerals. How many? We're talking about enough material to power a quarter of the world's future electric vehicles. The whole nation could become incredibly wealthy, but will there be anyone to claim it? Scientists doubt it for sure.
My, it's wet out here. In 2016, scientists decided to study the widest part of the Atlantic Ocean between Africa and South America. It's kind of lonely there. They went days without seeing a single plane or ship. It was mostly just dolphins and whales swimming by. They were in the middle of nowhere. So why? They were floating right above one of the most important geological spots on Earth, the Mid-Atlantic Ridge. It's where two monster tectonic plates meet. Tectonic plates are massive jigsaw pieces that are constantly moving, even though we usually can't feel them. They form the Earth's crust and, in this case, meet beneath the Atlantic Ocean. The researchers floated over the ridge and dropped down some instruments that detect waves, earthquakes, and other vibrations. A year later, they came back to collect the results. At first, the goal was to learn more about the history of the two plates. But the instruments picked up a whole lot more than that. They found out some stuff about the future, too. Way down at the bottom, there's a layer of extremely hot liquid rock that's constantly rising up, pushing on the tectonic plates and causing them to move apart from each other. That means that the Atlantic Ocean is expanding about 2 inches every year, pushing Europe and Africa away from the Americas. At the same time, its bigger neighbor, the Pacific Ocean, is shrinking. It's the biggest ocean, right now, with a huge area that's around 30% of the Earth's surface. Its average depth is 13,000 feet and is home to the famous Mariana Trench, the deepest spot in any ocean. And yeah, it's now shrinking by around 1/5 of a square mile per year. Some scientists even believe that eventually, millions and millions of years from now, the Pacific Ocean could completely disappear. This ocean is where we think most earthquakes happen, plus it's where a lot of the world's volcanoes are. All that causes lots of shaking. Plates move around and old parts of the Earth's crust get destroyed. The ocean floor can't grow fast enough to replace it. This means some big changes are coming in the future. A couple of inches isn't exactly a big deal, but after a few 100 million years, there'll probably be a new supercontinent on Earth. Australia is slowly heading north, and it could eventually collide with Korea, Japan, and eastern China. Africa is moving too. In 50 million years, it'll be pushing right up against the southern parts of Europe. Since it's all happening so slowly, I've had a chance to think up some future scenarios. Okay, not me. A bunch of super brainy scientists with even brainier computers. The first scenario, a monster landmass called Novo. The Americas would slam into Antarctica, then they'd team up and head over to Africa. Meanwhile, Africa would have already smashed into Europe and Asia. Not bad, at least you'd save some money on plane tickets. But for most people, it would take an epic road trip to get to a beach somewhere. The second scenario is Ultima. I feel like these all sound like car names. Anyway, in this scenario, the Atlantic stops getting wider. Actually, it's the opposite. It starts closing in on itself. This new super cool continent would be surrounded by the Pacific Ocean. Scenario 3. Orica. Both the Atlantic and Pacific Oceans eventually shrink down until they either disappear or end up like tiny little lakes. All the life in these two oceans is gone. Instead, some new ocean starts forming to replace them. And the new supercontinent? It has Australia in the corner, with the Americans and East Asia each on the opposite side of a small puddle that used to be the Pacific. The rest of the planet is one big unexplored super ocean inhabited by… who knows? I won't be around then. Number 4. Amasia. There's that car thing again. This one predicts Africa, Australia, and all the continents except Antarctica start moving north. Sorry, Antarctica, even planet Earth keeps forgetting about you. Better luck next time. Well, way off in the future, it might be possible to take a big old road trip across every continent, or drive across the African-South American border, or even get to Australia without having to take the longest flight of your life. But we've got a while to wait. What should I do for the next 250 million years? Binge watch some Brightside? Tectonic plates move at different speeds, some slower, some slightly faster. Your hair and fingernails actually grow at roughly the same speed as these beasts move. Imagine if everyone lived on one of those supercontinents. Animals would finally be able to cross continents and meet species they've never seen before. Leopards, rhinos, lions, elephants. Imagine if they got curious enough to set out on a journey out of their habitat. A lion might meet a polar bear. Kangaroos could finally leave the land down under, and birds that migrate to warmer places would have to totally reorganize their travel schedules. Who knows what the climate would be like? Playing around with the continental jigsaw puzzle isn't exactly a new thing. Our world didn't always look like this. 300 million years ago, our planet didn't have 7 continents. It had only one, a supercontinent called Pangaea. Pangaea was surrounded by only one ocean. Over time, it slowly started falling apart. At one point, South America, Antarctica, Australia, and Africa were one unit, and North America and Eurasia were another. Over time, these continents also splintered off, each heading in its own direction. Scientists have discovered many similar plants and animal fossils on continents that are separated by huge oceans. Even when you just glance at a map, you can see how Africa and South America look like two massive puzzle pieces that fit together perfectly. When you look at all the oceans and seas on a map, it may look like they just flow right into each other, like there's only one big ocean and people gave different names to different parts. You wouldn't think that if you've ever been to the place where they meet. The Atlantic and Pacific have a strict border that looks like an invisible wall separating two completely different worlds. You can clearly see different colors and waters, and they don't mix. Of course, there's no wall or any actual physical border, but not all water's the same. The Pacific and Atlantic have different densities, amounts of salt, temperatures, and a whole bunch of differences. The borders that separate two bodies of water are called ocean clines. The line you see dividing the Atlantic and Pacific Ocean is mostly caused by different salt levels. This is what layers of water with different salt levels look like. It's like they're separated with cling film. each one with a different color because it has different things growing in it. To see a clear, noticeable border, one sea or ocean has to be a whole lot saltier than the other. Want to get active and use up all the salt in your house? Pour some colored salty water or seawater into a glass bowl. Then add fresh water on top. Voila! The Pacific Ocean is the less salty one. That's because there are loads more rivers flowing into it. Heavier liquids are heavy, so they should sink to the bottom. But then, why is the border between the Atlantic and Pacific a vertical line and not a horizontal one? First, the difference in density of these two salty beasts may be enough to stop them from mixing, but it's not really enough to send one of them to the bottom with the other floating above it. There's another reason, and it's all about the Earth spinning around. Say you're flying from Chile to New England. If you fly straight north, by the time you get there, the Earth will have turned a bit, and you'd be nowhere near your destination. To get to the right place, the pilot needs to fly in a bit of a curve. That's sort of the same reason that currents move around in different directions. The currents in the Atlantic and Pacific Oceans move away from each other, so they don't really mix at their border, even though they're both just water. Confused? Yeah, me too.
7,500 years ago, the Pacific floor collapsed. Massive landslides buried the seabed in seconds. Fast forward to today, robot subs have examined the place. Scans have revealed proof of at least 10 distinct cyclical megaquakes. Now, researchers warn, the plates are still locked and building pressure, even today. If they start moving, that could trigger new red alert earthquakes and send disastrous tsunamis toward the coast. Let's look at the map. The fault here is like a giant zipper. It's over 600 miles, stretching from northern California to Canada. It's called the Cascadia subduction zone, and it's a part of the Ring of Fire. You know, the famous giant horseshoe around the Pacific that can serve as your where-to-go reminder if you're into volcanic and earthquake tourism. One of Cascadia's biggest events happened around the year 1700. There are no local written records of it, but there is a story. A well-known indigenous legend tells of an epic battle between a thunderbird and a whale. In the story, the thunderbird's wing beats make the ground shake. The whale's thrashing sends seawater flooding inland. The thunderbird wins by finally grabbing the whale and slamming it back down, shaking the land itself. Many researchers believe that this legend originated from the real earthquake of 1700. But we don't just have cool myths to give us the full picture. In the early 1700s, samurai officials recorded waves flooding villages and rice fields. But nobody felt the earthquake that must come first. That's why they nicknamed this event the Orphan Tsunami. But it did have a parent, and it took scientists 300 years to finally connect it back to Cascadia. To see Cascadia's past, researchers sent robot subs to scan the bottom in crazy detail. They expected to see a simple crack, but what they found looked more like giant underwater steps. Some of those steps are about 33 feet tall, like a 3-story building. That only happens when a big piece of the seafloor snaps off, breaks loose, and slides all at once, not slowly. When that happens, it kicks up a mud avalanche. Picture a jar of dirt and water. Shake it hard, and a fresh layer settles at the bottom. Each layer is basically a timestamp from a huge quake. When scientists counted and dated them, they found 10 separate megaquakes that hit one after the other over thousands of years. That means that Cascadia doesn't let pressure out little by little. It stays stuck for a long time, then suddenly breaks out violently. That pattern is why the Cascadia subduction zone is considered one of the scariest fault systems in North America today. So what's actually happening down there? The plates aren't sliding smoothly, they're stuck. And while they're stuck, the coastline is getting quietly bent out of shape like a ruler you're flexing in your hands. It doesn't look dramatic day to day, but it's been loading up for centuries. When that tension finally snaps, the coast will instantly drop. Geologists call this coast seismic subsidence. We're talking about the ground plunging 6 to 8 feet vertically in a matter of minutes. Imagine standing on a beach. The shaking stops, and you realize the ocean is rushing in. Not just because of a wave, but because the land you're standing on has physically sunk below sea level. That one move is enough to shove the seafloor out of position and force the ocean above it to react. Cascadia can produce a magnitude 9.0. That's top tier, categorized as the most destructive natural event that can happen. It can shake the ground for minutes, pushing and pulling everything back and forth until buildings and bridges start falling down. A 9.0 class quake also means the seafloor is vibrating and shifting, lifting in some spots, dropping in others, all in one sudden motion. A tsunami starts when the seafloor moves and pushes a huge amount of water out of the way. If the bottom suddenly lifts or drops, the water above it gets displaced instantly. That water has to go somewhere, so it races outward in every direction. Out in deep water, that wave is rarely tall. It spreads out across a long distance, so it can pass under ships without anyone noticing. The danger is speed. In the open ocean, tsunamis can travel around 500 to 600 miles per hour. That's like traveling from New York to Detroit in 60 minutes. Eventually, the ocean starts to pile up, getting taller by the second. Near shore, it can stack up to tens of feet, and in extreme cases, it can run up to 100 feet on land. It swallows the coast, then drags everything back to sea with a violent tug before the next hit arrives. But that's not all. When the fault snaps, it often triggers massive underwater landslides. When a huge chunk of seafloor collapses, it can shove water locally, like dropping a boulder into a tub. In the Cascadia subduction zone, you aren't just dealing with the earthquake's kick. You're getting a 1-2 punch from the shifting crust and the crumbling slopes combined. On parts of the Oregon coast, emergency experts say the shaking could last 5 to 7 minutes, long enough to realize what's happening and still won't be over. Then comes the scariest part. In some places, a tsunami can hit in 15 to 30 minutes. Remember, the earthquake is a warning. If you're on the coast and you feel strong, long shaking, you do not need to wait for a text alert or a siren, or someone on the news to yell tsunami. During the tremors, the basic recommendation is to literally drop to the ground, cover, and hold on, staying away from windows and chandeliers that can fall on you. As tempting as it is, we shouldn't stop to make a reel out of the situation. Before anything happens, make one decision while your brain is calm. Pick the closest high ground and go for it. Not somewhere uphill, an actual spot. If you ever needed a reason to learn your neighborhood, this is it. Your instinct might say, get into the car and drive. But don't. Roads are probably jammed and bridges could be damaged. People who live on the coast already know to keep it practical, with shoes on the bed and a go bag prepared just in case. The danger doesn't end with the first impact because the tsunami waves, well, they come in waves. The initial hit is rarely the largest, and the ocean can continue to pulse in and out for hours. This creates a violent tug-of-war. The receding water acts like a massive vacuum, dragging anything caught in the backwash out to sea. Japan's 2011 disaster is the most recent vivid example of what a magnitude 9.1 can do. The seafloor shifted in a single massive heave, and minutes later, the ocean literally rearranged the coast. A huge wall of water crashed inland, reaching over 100 feet high in some spots, and turning the coastline into a conveyor belt of debris. It was like water turned cars into giant bowling balls and shipping containers into massive metal bricks, smashing ports and drowning low-lying airports and electrical substations. Finally, what do officials say about the timeline for the possible next disaster hitting Cascadia? Well, they can't give us precise dates, but they did announce some odds. For the biggest, scariest earthquake possible, The United States Geological Survey says there is about a 10% to 15% chance it'll happen in the next 50 years. Chances for a quake that isn't the mega version are 1 in 3 in the next 5 decades. Those odds are actually pretty high. But here is why it isn't all that grim. Scientists know this isn't random. Cascadia has a pattern, and patterns are what preparation runs on. We already know how to build for big shaking, and we're getting better at spotting where stress is building. It doesn't mean we can stop the earthquake, but it means we're getting way better at knowing what to expect. In the meantime, just keep a go bag by the door and maybe take a walk around your neighborhood every once in a while.
You're sailing on a calm ocean when you see it, a giant wave rising out of the water, towering over your boat. Uh-oh. But before you can react, the deck suddenly disappears beneath your feet, and you're falling into a deep and vast pit in the sea. Neither outcome gives you a chance to survive. Apparently, the ocean can both crash down on you and suddenly drop away beneath your feet. It's not your day. Well, in the first case, it will be a giant rogue wave. These waves are huge and dangerous ocean waves that appear suddenly and are at least twice as tall as the waves around them. These waves can rise up in the open ocean without warning and may move in a different direction than the wind and other waves. They're extremely dangerous, even for big ships, because they form super quickly and grow to be exceptionally large. But there's even a scarier threat in the ocean: rogue holes. Those are massive pits in the water, and until recently, no one could confirm their existence. They are the opposite of rogue waves. Instead of a huge wave rising up, they are deep dips in the ocean that appear suddenly, sometimes just before or after a big wave. The water drops sharply, often surrounded by normal-sized waves on either side. When the difference between the top of the waves and the bottom of the dip is much bigger than normal, it can be just as dangerous for ships as a giant 80 to 100-foot wave. Now, scientists have figured out that big waves and deep dips often happen together, so the danger they present now doubles. ESA's Max Wave project was studying rogue waves when they found evidence of rogue holes. After that, researchers even recreated rogue holes in a large water tank to study them safely. And they found out that, apparently, rogue waves and rogue holes come from the same hidden pattern in the ocean. You see, the Max Wave project didn't officially list rogue holes as a separate type of wave, but scientists did notice something unusual in their data. They saw deep drops in the ocean surface appearing together with very large wave peaks. This suggested that rogue holes might exist, but there was not enough evidence to confirm it. To test this idea, a team of researchers at Kyoto University recreated ocean-like waves in a long wave tank, about 50 feet long. It worked like a controlled mini-ocean where scientists could carefully adjust wave size and speed. Inside this tank, they were able to create both giant rogue waves and deep rogue holes. The rogue holes looked like sudden voids in the water, deep dips surrounded by normal-sized waves, like the ocean briefly sank down in one spot. It's similar to a sudden pothole appearing on the road, but filled with moving water instead of asphalt. So imagine normal waves as fast, repeating bumps moving across the water. Now, imagine a much slower, bigger wave on top of that. It looks like a rolling hill that lifts everything up and down. This bigger wave controls how strong the smaller waves are. If the hill hits a wave right when it's already at its highest point, the wave grows into a huge rogue wave, as if someone stacked one wave on top of another. But if that same hill pushes down when a wave is at its lowest point, it creates a deep hole in the water instead. It's like the ocean suddenly drops beneath your feet, So it's the same process, just timed differently. At times, it creates a giant wall of water, and at other times, it's a sudden dangerous drop. So the results of the experiment matched the mathematical predictions. They proved that those strange wave patterns were not just a theory, but something that can really happen in the ocean. In 2016, scientists compared mathematical models with real ocean measurements and found patterns that match both giant waves and deep holes in nature. Of course, in the real ocean, these shapes are not perfectly smooth like in experiments. The waves often have sharper, uneven edges, like a hill that is steeper on one side than the other. But even with these differences, they still followed the same hidden structure. This confirms that rogue waves and rogue holes are really two kinds of the same ocean event. They're just shaped differently by timing and energy. Meanwhile, we still really don't know the ocean. Most of it is a mystery to us. Less than 1/1000th of the seafloor has been seen up close. Imagine the size of Rhode Island or Luxembourg, hey, pick one. That tiny bit is what we have mapped. Everything else, deep trenches, cracks, caves, massive underwater mountains, remain blurry on our maps. Many phenomena went unexplained for centuries, too. For example, sailors kept reporting enormous waves that suddenly towered over everything else, sometimes more than twice the height of normal waves. Back then, most people thought these reports were exaggerations, like spotting mermaids or a giant squid. But those waves were real. Now, in 1826, Dumont d'Urville, a French naval officer and explorer, sailed the Indian Ocean on the ship Astrolabe. Yeah, it's a bad French accent. He saw waves of at least 80 to 100 feet tall during a violent storm that took the life of a crew member. At that time, scientists thought waves couldn't exceed about 30 feet. So, even though his account sounded unbelievable, D'Urville insisted on recording it. And guess what? Yup, instead of being praised, he was laughed at. Okay, I'll stop. Now, even earlier, in August 1498, during his third voyage to the Americas, Christopher Columbus and his crew heard an enormous roar from the sea and saw a wave rising behind their ships. It was as tall as the masts. The wave lifted the ships higher than anything they had ever experienced, and then dropped them into a massive trough. It was like a roller coaster made of water. Now, modern oceanography has confirmed that such colossal waves do exist. They're like skyscrapers suddenly appearing in the middle of a calm sea. A normal wave might be tall enough to reach the roof of a 2-story house, but a rogue wave can tower like a 10-story building. In 1861, such a wave apparently smashed a lighthouse in Ireland. It shattered lamps and sent debris tumbling down a lighthouse staircase. To do that, the water had to climb a 130-foot cliff and then an additional 85 feet of the lighthouse structure. It's almost as tall as a 20-story building. Rogue waves appear suddenly, often without warning, in the middle of the ocean. These waves form when winds, currents, and smaller waves line up just right, making a single giant wave much taller than the others around it. They aren't tsunamis and aren't caused by earthquakes or volcanoes. Physicists model this using something called the nonlinear Schrödinger equation, but basically, it just explains how the ocean can suddenly make a giant wall of water. On January 1, 1995, the Dropner wave struck an offshore gas platform in the North Sea off Norway. It measured 84 feet. This was the first time a rogue wave was officially recorded, proving those monster waves were real. But scientists still consider them rare. Well, by the year 2000, the European Space Agency's Max Wave project confirmed that rogue waves were more common than anyone thought. Using radar from ESA satellites, scientists studied the global ocean and found many waves exceeding 82 feet. Some of the largest recorded waves even reached 98 feet near Newfoundland. Suddenly, what people used to brush off as sailor stories turned out to be terrifyingly real. On the 17th of November 2020, a weather buoy near Vancouver Island, Canada, recorded a very unusual wave in the Pacific Ocean. The wave reached about 58 feet, while the surrounding waves were only about 20 feet. This made it much larger than normal waves around it. On the 29th of November 2022, a rogue wave hit the cruise ship Viking Polaris near Antarctica. One person lost their life, several others were hurt, and the trip was canceled. On the 18th of September 2023, a large wave hit a beach restaurant in South Africa. 7 people were injured, and one person was swept out to sea but luckily rescued. And on the 20th of January 2024, powerful waves hit a U.S. military site in the Marshall Islands. Buildings were damaged, some areas were flooded, and waves moved far inland, showing how destructive these events can be.
You're chilling in Hawaii, on the island of Oahu. A friend calls you up. Hey, I'm here too. Meet me in Maui. Great, but how do you get there? Your first thought is probably to take a ferry, but that's impossible. Hawaii is a pretty unique place. It's the most expensive state to live in. It has its own official language besides English. And it's the only American state made up entirely of islands. Hawaii has a total of 137 islands. 8 are the main ones, but only 6 are open to tourists. And the distance between those islands is probably bigger than you'd expect. For example, traveling from Oahu to the Big Island is around 185 miles, which is about the same distance as Chicago to Indianapolis. You might be surprised that you can't make that trip by boat. In fact, the only ferry system that actually takes passengers in Hawaii runs between Maui and Lanai. That's it. So your only option is to travel between islands is by plane. Honestly, it's a little surprising, especially considering how many people visit Hawaii every year. Tourism pretty much drives their economy, and in the first 8 months of 2024 alone, over 6 million people visited its beautiful beaches. Knowing that, we would expect Hawaii to set up a good ferry system to make it easier for visitors to get around. Just like in Greece. This would probably boost tourism even more, bringing more money to the state. But believe me, authorities and private companies also know that. In fact, they've already tried it. Ferries were a big way of getting around in Hawaii from the 19th century up until the 1950s. Since then, there have been a few attempts to bring back a ferry service, but unfortunately, they have all failed. One of the biggest attempts was the Hawaii Super Ferry, which aimed to provide a fast, affordable boat service between islands. It could carry almost 900 passengers and even allow them to bring their own cars along. The trial run started in 2007, and people were excited, but it turned into a big fiasco. A bunch of legal and environmental issues came up, like concerns about the impact on marine life, especially whales. The courts decided the ferry didn't go through the proper environmental reviews, and that caused a lot of trouble. By 2009, after tons of protests and setbacks, they had to shut it down. If a project like this comes up again, it will probably fail one more time. And there are a few reasons why it's almost impossible to set up a regular ferry system there. Let's start by talking about Hawaii's rough waters. They are deep and wild. Take the Alenoiaha Channel, for example. It's a 30-mile stretch that separates Maui from the Big Island. Its name means Great Billow Smashing Channel, and it lives up to that. It's over 6,000 feet deep, making it one of the most dangerous stretches of water on Earth. The wind there is also super strong, the fastest in Hawaii's coastal waters. But it's not any easier in the rest of the archipelago. The whole region gets hit by storms from the Pacific up north, sending big waves crashing into the islands and making the waters rough and unpredictable. Swells can come from 3, 4, or even more directions, making the sea feel really choppy. Someone who's not used to taking ferry boats would definitely find that, well, uncomfortable, to say the least. To deal with rough seas like this, the ferries have to be really big and strong. But that also makes them more expensive and harder to run than the ones in places like Alaska or Washington State. Another reason it's so tough to set up this system today has to do with marine life. A big ship moving through the shallower waters when docking could really damage the local ecosystem. And there's also the problem that the sea routes are also the migration paths of many sea animals, like humpback whales and spinner dolphins. Not to mention, ferry services can make it easier to spread harmful plants and animals, what experts call invasive species. See, Hawaii's ecosystem is super unique because it's been isolated out in the middle of the Pacific. When we talk about plants and animals that are native to Hawaii, we mean they got there on their own, no humans involved. They arrived with the help of waves, wind, or even birds flying over. But events like these are super rare, so for over 70 million years, their plants and animals didn't have to deal with outside competition. That's made them really fragile. So, when new species get brought in by us, it can be a big problem, and they could end up harming the environment. Hawaii's already been battling invasive species like fire ants, coqui frogs, and meconium, a fast-growing plant from South America that takes over native forests. People there worry that ferries, which carry cars and cargo between islands, could accidentally spread these invaders even more. Like we mentioned at the beginning of the video, the long distances between their lands don't really help either. For example, if you were to travel from Oahu to the big island of Hawaii by boat, it would take around 30 hours, and that's without any stops. The same trip by plane takes about 50 minutes. Ferries that cover long distances are much more expensive, so they need a much bigger demand to make them profitable. On top of that, the state doesn't really have the infrastructure, like enough ports and terminals to support the operations. So setting up new routes is pretty much out of the question. Airplanes, on the other hand, are a different story. The air travel industry in Hawaii is already well established and super competitive. That means flying is still the most practical option in Hawaii. Planes are quick, they don't make you seasick, and are pretty affordable, usually costing around $100 for a round trip. Okay, but what do the locals think about all this? Well, apparently, there isn't a huge demand for residents to commute between the islands all that often. Oahu is the busiest island in Hawaii, with about 70% of the state's population living there. It is where Honolulu, the capital, is located, and where most of the state's business happens. So, people from the other islands usually come over for a specific doctor's appointment or to catch a big concert. And that might happen once or twice a year, no more than that. So, even if people could choose between taking a ferry and a plane for these special occasions, most of them would probably still prefer flying. There are plenty of options between the main island airports. Planes usually start flying around 5 in the morning, and there are flights available every hour until the last one, which is usually at 9 in the evening. If you've been dreaming of going to this paradisiacal place but are worried about spending too much on plane tickets, I have some tips for you. First off, keep in mind that visiting all the main islands in 5 days or less is way too ambitious. So, if you don't have much time to spend there, think about your priorities. Each of the 6 islands open to tourists has its own vibe and activities. But you don't need to visit them all in one trip, and you can save some money by sticking to fewer islands. You can still explore the diversity of the islands by picking 2 that offer a nice contrast to each other. For example, While Oahu has that bustling city energy, Kauai has a much more relaxed vibe. Also, flights in the morning are usually cheaper, and it might be better to fly on a weekday rather than the weekend, although the price difference isn't usually huge. Hopefully these tips will save you some cash while still having an unforgettable island hopping adventure in Hawaii. Don't forget to share this video with a friend who's also dreaming of exploring these amazing islands. Something is about to reshape the entire future of the West Coast. The coastline, the infrastructure, the whole map. Scientists fear there is not one but two big earthquakes coming, one caused by another. This wasn't even on the radar for most people, but new research is changing everything. For decades, everyone treated the San Andreas Fault and the Cascadia subduction zone like two separate monsters that just happened to live in the same neighborhood. They were powerful, yes, but independent. But now, scientists believe these two giant faults are mechanically linked, and one can literally pull the other into rupturing shortly afterward. Cascadia moves, San Andreas moves. San Andreas tears, Cascadia tears. And the potential consequences of that are honestly haunting. Scientists found evidence that it happened at least 10 times in the last 3,100 years. Earthquake, pause, earthquake. It comes from marine sediment cores, which are like time capsules pulled up from the ocean floor. Researchers analyzed layer after layer of seabed sediment and found doublets. Paired debris layers created by two massive quakes happening so close together that the ocean barely had time to settle between them. That discovery takes us to the Mendocino Triple Junction, the geological troublemaker of the West Coast. It's the place where three tectonic plates crash and grind into each other like badly aligned gears. It's also the zone where the San Andreas meets Cascadia, which makes it the perfect place for these double quakes to form. The stress changes caused by a rupture in one fault travel straight through this junction and destabilize the other. It's benign when it happens to a bookshelf. When you move one book, three others shift. But when you think about it like a coastline with millions of people, entire cities, major infrastructure, it instantly feels terrifying. To many people who live on the West Coast, the San Andreas kind of feels like a California's problem, and Cascadia like an Oregon and Washington's problem. But when you understand that these two faults can essentially fire at each other, it stops being a local issue and becomes a continental one. A Cascadia megaquake alone can hit magnitude 9.0 plus, rip open 600 to 700 miles of seafloor, and send a tsunami roaring toward the Pacific coast. And it could just be the first quake, and then, maybe minutes later, the San Andreas snaps in Northern California. The shaking could ripple down the state like a zipper tearing open a jacket, and if it goes the other direction, it could be just as bad. If the San Andreas ruptures first, the intense stress redistribution can destabilize the Cascadia subduction zone. You could get the California quake first with buildings rocking, highways breaking, and power stations failing. And then, soon after, the ocean pulls back in Oregon or Washington. And the 20-minute countdown to a tsunami begins, a follow-up disaster. It's the kind of chain reaction you don't want even in a video game, let alone real life. This discovery also tells us something eerie about the earthquake in 1700, the one that sent a tsunami across the Pacific so huge that it struck Japan with no warning. Japanese fishermen called that wave the orphan tsunami because it arrived without any felt shaking. Only centuries later, scientists figured out that it came from the Pacific Northwest. But until recently, no one knew that the San Andreas might have felt that event too, and it possibly slipped or destabilized because of it. So, the whole West Coast may have moved together. And we've come to the scariest part. All this isn't about if, it's strictly about when. The faults have a rhythm, a pace, and a geological heartbeat. We've seen how they behave across thousands of years. We know what they did, and now we know they sometimes do it in sequence. The real fear isn't the first quake. California already expects a big one. The real fear is the second quake, the one that comes before you've checked on your family, before emergency responders regroup, before the power comes back, and before the dust settles. Even if you don't live on the West Coast, this matters for you too. The ports in California, Oregon, and Washington handle a massive chunk of America's imports. Knock them offline, and it's not just the coastline that feels it. The ripple hits the entire country and potentially the world. Grocery prices spike, supply chains freeze, gas availability dips, shipping timelines go nuts. The world is much more connected than any of us thought, and a geological double punch on the Pacific coast wouldn't stay a local disaster. It would spread, thread by thread, into everyone's life. So, those in power must prepare not for one giant rupture, but for two. Emergency plans, evacuation routes, response times, and power grid designs, all of it needs updating. Because nature has now shown us what even a single major rupture can do to a modern economy. It happened in Japan in 1995, on January 17th at 5:46 in the morning. The quake hit right by the northern tip of Awaji Island, only 12 miles from Kobe, a huge, busy city with about 1.4 million people back then, and another 2.6 million in Osaka nearby. The rupture ripped along the Nojima Fault for about 25 miles. That doesn't sound like much until you realize entire buildings can't survive that kind of sideways shove. More than 5,000 people lost their lives. 43,000 were injured. Nearly 400,000 buildings were irreparably damaged. This disaster hit one of Japan's largest industrial zones. And when you mess with a place like that, the shock doesn't stop at the shoreline. The damage was $200 billion US in losses, from smashed buildings and infrastructure and many businesses shutting down. Kobe's port just collapsed. Only 30% of the Osaka-Kobe railway lines worked. Part of National Route 28 literally vanished into the ground. Schools, hospitals, and municipal buildings, 85% of them took damage or were unusable. Fires broke out across Kobe, almost 300 separate incidents, burning the equivalent of 70 US city blocks and taking another 600 to 700 lives. Almost 100,000 people permanently left the region, 2.5% of the whole population gone in less than a year. And here's a detail that stuck with me. So many bridges failed that engineers suddenly had to confront how poorly older designs handled lateral shaking. Houses with heavy tiled roofs, built to fight typhoons, crumbled because all that weight sat too high. But the newer homes made after the 1981 building code revision stood. And that's when Japan realized that modern seismic standards were crucial to follow. Japan threw $58 billion US into restoring the region. Power came back in days. Roads and rail returned in 5 to 8 months. The main expressway took 21 months. The port was fully rebuilt in just over 2 years. And by then, all debris was cleared. Within 15 months, manufacturing jumped back to 98% of its old level. Stores reopened. By 1999, Kobe's economy reached roughly 75 to 90% of pre-quake levels. Japan overhauled its disaster management system entirely. They set up the Central Disaster Management Council and rewrote building codes. They upgraded everything from emergency drills to fire-resistant city layouts, and they launched the Earthquake Early Warning System that now gives Japan those precious few seconds before shaking hits. The same system that saved countless lives since 2007. But despite all this improvement, the Kansai region still sits on dangerous ground. The Roku-Awaji-shima fault system, the same one that snapped in 1995, still runs under them. The 2018 Northern Osaka quake and the 2024 Noto Peninsula quake reminded everyone that this threat didn't disappear. It just waits its turn. A future large event on that system could hit even harder simply because the region has grown more complex, more interconnected, and more economically loaded. So Kobe wasn't even a triggered double fault rupture, but it still broke a major industrial hub, reshaped a national economy, and permanently changed global shipping routes. That's why when scientists started talking about two joint faults firing off back-to-back in Cascadia and San Andreas, you don't even have to imagine the consequences. We already got a preview in 1995.
Oh wow, there's a hole in the bottom of the ocean. It seems that the ocean has a leak.
But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's Oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's Oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Shoreline. The site of Shoreline was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space, too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn.
Well, here you are. You're getting into your submarine, feeling a bit anxious. You're going to descend hundreds of feet underwater to explore the ocean floor. So many things can go wrong. Technical issues, insane water pressure, dangerous marine monsters, mysterious eerie sounds. Wait, what? Eerie sounds so deep underwater? Yep, a strange humming noise is coming from the ocean depths. What makes it even creepier is that it only appears during dusk and dawn. This noise might act as a dinner bell, since it's likely to have a connection to massive groups of sea creatures moving up and down through the water to feed. But so far, it's just a theory. Using highly sensitive underwater microphones, researchers recorded a mysterious low-frequency hum at depths of 660 to 3,300 feet. The sound wasn't very loud, just 3 to 6 decibels above the usual ocean background noise. For comparison, when someone is whispering in a quiet library, the sound reaches 30 decibels. The underwater noise also had a puzzling or humming quality. The weirdest thing? Despite their efforts, the researchers couldn't pinpoint a single species responsible for the sound. The noise originates in a region known as the Twilight zone of the ocean. This region is dark and doesn't have many nutrients, with no sunlight for photosynthesis. Life here relies on organic debris falling from above, such as deceased organisms or waste material. At the same time, while it may sound barren, The Twilight Zone is far from empty. A 2015 study estimated that up to 90% of the world's fish could live in this zone, including many undiscovered species. Now, back to the mysterious noise. The researchers believe the sound may be linked to the vertical migration of small marine creatures like fish, shrimp, and squid. These animals move upward toward the surface at sunset to feed on plankton and nutrients, using darkness to avoid predators. At sunrise, they return to the depths to hide. This migration, which is one of the largest animal movements on Earth, involves billions of organisms and occurs daily. Scientists suspect that the strange hum might occur during this migration, as a way for the creatures to communicate or coordinate their movements. It might also serve as a signal to indicate when it's safe for a group to go to the surface and feed. If some animals indeed use the hum to communicate, it could help us understand deep-sea life better. The Twilight Zone has always been considered a quiet environment, but such a discovery hints at complex social behaviors and interactions among its inhabitants. But it's not only the ocean that produces bizarre sounds. Earth is humming non-stop too. Unfortunately, you can't hear this soundtrack. This hum isn't from earthquakes. It's produced by subtle ongoing vibrations in the planet's crust. They're too faint for us to feel and can only be detectable with special equipment. Scientists have long known about this phenomenon called free oscillation and have recorded this persistent hum. Earthquakes are the most noticeable ground movements. According to the U.S. Geological Survey, Earth experiences about 500,000 earthquakes every year. Of those, only 100,000 are strong enough to be felt, and around 100 cause noticeable damage. But in the quieter moments between earthquakes, the planet is still constantly vibrating with smaller, unnoticeable movements. Unlike the sudden jolts of earthquakes, this hum is steady and uniform, and it's a byproduct of microseismic activity. Seismometers, tools used to record ground vibrations, can detect this sound anywhere on land. For years, researchers have been debating the origins of this hum. Some thought it came from ocean waves reaching deep into the seafloor. Others believed it was caused by colliding waves on the ocean's surface. By 2015, scientists had confirmed that both factors contributed to Earth's constant vibration. And although this hum has been recorded on land, now we also have much clearer, more detailed underwater recordings. To study the hum, researchers used spherical seismometers on the seafloor in the Indian Ocean near an island east of Madagascar. Between September 2012 and November 2013, they placed 57 freefall seismometers across a 772 square mile area. These devices are designed to sink into the ocean floor and record even the faintest vibrations. Over the course of the 11-month study, the team filtered out noise from ocean waves and seafloor currents. They got clear, consistent signals of Earth's hum, with peaks at frequencies between 2.9 and 4.5 MHz, far below the range of human hearing, which starts at 20 Hz. The discovery of Earth's hum from the ocean floor is more than just a scientific curiosity. It gives researchers a new way to study how energy moves through the planet's crust and mantle. In any case, the world around us is filled with weird sounds that sometimes remain unexplained. One of the most intriguing examples is the bloop, an incredibly loud underwater sound recorded in 1997 by the U.S. National Oceanic and Atmospheric Administration. The sound lasted about a minute and began as a low rumble, which then increased in frequency. It was so loud that underwater microphones detected it across an astonishing 3,000 miles. Initially, some experts thought it was the call of a massive unknown sea creature. However, NOAA later determined that the source likely had been the calving of icebergs, when giant pieces of Antarctic glaciers had been breaking off and crashing into the sea. The sound, known as Julia, a strange cooing noise, could have been produced by an iceberg scraping along the ocean floor. Another sound, dubbed train, due to its resemblance to the sound of train wheels on a track, likely originated in Antarctica's Ross Sea. Then there is upsweep, a recurring seasonal scratchy noise detected in the Pacific Ocean since 1991. Despite years of research, its exact cause remains unclear. The underwater world also has bizarre sounds that can be described as choirs of fish. Scientists studying marine life off the coast of Port Hedland in Western Australia discovered that many fish species sing in synchronized choruses at dawn and dusk, much like birds. Over 18 months, researchers recorded tons of sounds, including foghorn-like calls from black jewelfish and rhythmic ba-ba-ba sounds from batfish. These fish songs, which often involve repetitive calls that overlap in large groups, are especially important for breeding, feeding, and territorial behavior. Deeper in the ocean, NOAA researchers also explored the sounds of the Challenger Deep, the deepest part of the Mariana Trench. They used a titanium-encased microphone that managed to survive the crushing pressure, over 1,000 times the atmospheric pressure at sea level. Over 23 days, the recorder captured loads of noises, from the haunting songs of whales to the rumble of distant earthquakes. Now, we've already figured out that the ocean is filled with strange sounds, but you can also hear weird noises above ground. One of the most puzzling is the hum, a low-pitched noise reported by people in specific areas, such as Taos, New Mexico, or Bristol, England. The sound is often described as a faint engine-like drone, and its source remains a mystery. Some researchers think it might be a psychological phenomenon, where people focus on subtle background sounds they might otherwise ignore. In any case, no definitive answer has been found yet. Geological formations can sing too. Utah's Rainbow Bridge, a massive 300-foot-high sandstone arch, vibrates like a guitar string when exposed to sounds, distant earthquakes, or waves near Lake Powell. Scientists have studied its frequencies to understand how such vibrations could affect the bridge's stability over time. Interestingly, visitors to the Rainbow Bridge have reported hearing faint humming sounds too. The skies also have their own eerie noises. For centuries, people in polar regions have described faint sizzling, popping, and cracking sounds, accompanying auroras. A Finnish researcher made the first known recordings of these sounds and traced their origin to electrical discharges in the lower atmosphere, about 230 feet above the ground. These charges, caused by magnetic storms fueling auroras, produce faint sounds during calm and clear nights. Other natural phenomena, such as icebergs grinding against the seafloor or volcanic activity on the ocean floor, produce groans, rumbles, and crackling sounds that scientists study to learn about glacial movements and underwater geological activity. I myself produced many unusual sounds and rumbles, but, that's a subject for another video, or my next annual review.
Okay, let's try something together. Open any world map you have available. It can be the one you find in your bookcase or even an online version. Take a look at the vast area covered by water. That's 71% of the Earth's surface. And all that is salt water from the world's oceans. There aren't any borders between the four oceans we've all come to know, but oceanographers and the world's countries did traditionally split these waters into four distinct regions: the Pacific, Atlantic, Indian, and Arctic Oceans. And here comes the big surprise. The scientific community has recently recognized the fifth body of water. It's called the Southern Ocean, and three of the four original oceans border it. It circumnavigates Antarctica and the lower portion of the globe and reaches Australia and the southern portions of Africa and South America. What makes this ocean so special? How did the scientific community eventually recognize it? And more importantly, what mysterious creatures does it hide? Let's find out. The Antarctic Ocean, or the Southern Ocean, was first mentioned back in 1937 in the second edition of the International Hydrographic Organization's Limits of Oceans and Seas. That's a mouthful. Back then, this organization considered that it was wrong to consider the Antarctic Ocean as its own distinct body of water. Why? Well, because at that time, an ocean was defined as water surrounded by land, and not water surrounding land. However, they reconsidered it in 2000 and voted to include this ocean in the official list. They also decided on the name Southern Ocean over the commonly used Antarctic Ocean. Finally, the organization concluded that the ocean should be considered as ending at the 60th parallel south latitude. But how old is this ocean? Well, many specialists believe it to have formed only 30 million years ago, which would make it the youngest of the world's oceans. It was created when Antarctica and South America moved away from each other during the early stages of our planet's development. This unique water current is a distinctive component of the Southern Ocean, as it helps keep the waters flowing around the icy continent. It's called the Antarctic Circumpolar Current, and it moves to the east with incredible speed. It's estimated that it moves an enormous amount of water per second. Some of the disputes regarding the Southern Ocean also have to do with this amazing current. Some specialists believe it separates the water of the Southern Ocean from the waters of the nearing Atlantic or Pacific. Only the rapid circulating water is considered the Southern Ocean. On the other hand, though, a handful of scientists say that the current actually makes the naming issue more complex by not limiting the waters to a specific geographic location. They believe that the waters in the current are different in terms of composition from waters in the northern oceans because they are way colder and have a lot more salt. Sailors don't really like this new body of water, mostly because of the frequent cyclone-like storms that it experiences. They happen because of the big temperature difference between the ice packs and the ocean waves. As a result, these storms are very difficult to surpass for any sailors that happen to encounter them. I mean, really, these are the strongest winds found anywhere on our planet. More so, the vessels going through this area must also be wary of the frequent icebergs that may pop up every now and then, and also of the low surface temperatures. Just to paint you a better picture, some of the icebergs found here can span over several hundred meters and can exist all year round, regardless of the season. The latitudes from 50 to 70 have even earned the nicknames of Furious 50s or the Shrieking 60s because of these intense year-round storms. Even the landscape is unique. They say the Southern Ocean has bluer glaciers, colder air, and more intimidating mountains than anywhere else in the world. Now, let's get to the mysterious creatures that call this place home, as thousands of species of wildlife live only here and nowhere else in the world. Let's start with the quirky sea pig, or one of the sea cucumbers as it's sometimes called. There are a lot of them in the waters off Antarctica. Why is it called that way, though? Because of its pink hue and round, bloated looks. On a closer look, it even appears to have a little tail and set of ears, just like a pig. They do help a lot with the quality of the waters here, filtering sand and sediment. Then there are the Hoff crabs that live on the floor of the Antarctic Sea. The Southern Ocean is a cold water environment, but crabs are more adapted to warmer waters. So, Hoff crabs gather around the warmth made by volcanic vents. They get the needed warmth and food here. You can find them in large piles, one on top of another, literally filling the space at the vent openings. Now, wonder how they got their unofficial name? Well, it's because of their apparent similarity to the actor David Hasselhoff, whose impressive chest reminded explorers of the crab. Okay. Ever seen a fish that's completely transparent? You'd have to get to these waters down in the south, but they do exist, and they are simply called the ice fish. You can basically see inside them, being completely clear and all. That's because of their see-through skin and because they don't have any red blood cells. Their special power is that they can use antifreeze to prevent their bodies from going solid in the cold waters of the Southern Ocean. Instead of the standard thicker blood, the red one with hemoglobin, ice fish have thinner blood that moves around more easily throughout their bodies, hence giving them the much-needed nutrients and oxygen. Now, is there a monster hidden in these waters? Some people believe this to be the case, and thanks to recent research, we even have video footage of it. Some Australian researchers stumbled upon a bunch of weird-looking creatures that were swimming near the seafloor of the Southern Ocean. This pink blob-like fish seemed to be propelled by a little pair of fins. To quote them on it, it seemed to resemble a chicken just before you put it in the oven. I'm not sure I even want to know what that looks like. It took them some time and research to identify the monster. It's a shy species of sea cucumber, known more by its creative nickname, the headless chicken monster. We've known this creature has existed since the late 1800s, but we've barely ever seen it. And we've only ever captured it on tape once before when it was spotted in the Gulf of Mexico, which is quite far from the waters off the coast of East Antarctica. There's so much we don't know about this creature, like how many of them exist in our waters and how they live, eat, and reproduce. Ever heard of the emperor penguin? It's not a penguin species that just happens to have a crown on its head, if that's what you're thinking. But they are one of those penguins that inhabit this specific location and are also the largest species of their kind altogether. What makes them special is that they make their colonies on the sea ice, and most of them never step foot on land. More so, penguin dads lose almost half their weight while incubating the eggs. They're also fascinating swimmers, able to dive deeper and longer than any other bird, up to 700 feet. Not to mention they can stay submerged for up to 18 minutes at a time as they gather food. We have yet to uncover all the secrets of the mysterious Southern Ocean, but it's clear that it's home to some unique and fragile marine ecosystems. Recognizing it as a new ocean could be one way to focus the public attention on it and help its conservation.
The Kikai Caldera is being recharged, and that might trigger one of the most destructive eruptions we've ever seen. It would not only destroy parts of Japan, but also affect the lives of millions of people around the world. And if this new study is right, Kikai might not be the only threat. Other massive calderas like Toba and Yellowstone could be on the same path. The Kikai Caldera is an active volcano system near Kyushu Island. Unlike traditional volcanoes with a visible peak, a caldera is a giant crater left behind by past eruptions. In Kikai's case, much of it is hidden beneath the ocean, so it's hard to know exactly when it might erupt. But scientists just found a large magma chamber beneath it, and it is slowly filling up. That's super concerning, because we're talking about one of the most dangerous volcanic systems on Earth. Around 7,300 years ago, it triggered the largest eruption in our current geological era. It spread ash and rock across 1,700 square miles. That's like 3 times the size of Los Angeles. This event is known as the Akahoya eruption, and it was probably what wiped out a prehistoric community living there at the time, known as the Jomon people. Kikai has not done anything nearly that dramatic since, but the next major event may be closer than we think, because that huge magma reservoir scientists have just found is probably the same one that fed the Akahoya eruption. The problem is that the magma inside does not appear to be leftover material from that ancient blast. It looks new. That changes the story completely. This is not old heat slowly fading away. It's a big volcano being recharged, and that raises new concerns about its potential to erupt again. The stakes are now much higher than they were 7,000 years ago. Back then, the region was home to scattered communities. Today, an eruption like this could affect the lives of 120 million people. Volcanic ash could cover a huge area, destroying homes and shutting down electricity, gas, and water services. It could also block roads and highways, paralyzing transport and cutting off food supplies. The destruction would not stop in Japan. It could also trigger tsunamis and earthquakes later on. At the same time, volcanic ash could block sunlight and lower global temperatures. That damages crops, leading to food shortages around the world and major economic losses. Even if nothing like this happens, this discovery still matters. It puts us one step closer to understanding when the next big eruption might happen. Researchers now want to refine the methods that worked so well in this study, so they can better understand how volcanic systems are refilled. If they succeed, we may find that other giant calderas like Yellowstone and Toba are on the same path. And by spotting the warning signs of a giant eruption earlier, we could have a better chance of protecting ourselves. Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more, but getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city, except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. they don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria. But hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system. For 70,000 years, Taftton Volcano successfully convinced everyone it was extinct. But new satellite images show that its summit is rising, like something inside is stretching it, rolling it over, and cracking its neck after the world's longest nap. Scientists aren't too happy about it, so let's see if you have a reason to be worried too. Volcanoes can wake up when earthquakes shake them awake or storms mess with underground water. But scientists checked. There weren't any big earthquakes or heavy rains in southeastern Iran, where it sits. So it must be gas or magma pressure that's moving Taftton. It's like a sealed soda can heating up from the inside. Before you even hear a hiss, the pressure is building silently, waiting for a weakness. That's why Taftton's movement is such a big red flag. Pressure changes mean new internal activity. Plus, the source of pressure below its surface is at just around 1,600 to 2,070 feet deep. And that's not a lot for a volcano. When the source of pressure sits that close to daylight, it can set off small explosions from steam or gas, even if no lava ever touches the surface. This type of explosion, called phreatic, happens when water underground gets so hot so fast that it blows up like a giant pressure cooker. In Hollywood movies, volcanic eruptions always look like rivers of lava chasing people down the street. But steam-driven explosions are different, sneaky, and unpredictable. One minute everything looks calm, and the next minute rocks and superheated steam blast into the air like Earth sneezed with the power of a jet engine. For Taftton, this is exactly the scenario scientists are afraid of. You don't need flowing lava to cause destruction. A steam-driven explosion can launch boulders the size of cars and shoot ash clouds thousands of feet up. Even if you don't live anywhere near Iran, Taftton isn't just a local issue. Volcanoes breathe out gases that travel with the wind, and Taftton produces sulfur-heavy emissions when it's active. Sulfur dioxide doesn't just smell bad, but messes with air quality, irritates lungs, and reacts in the atmosphere to form particles that can dim sunlight and cool temperatures. That means neighboring countries might feel the effects even if they never see the volcano. And if a phreatic explosion blasts ash high enough, it could drift into international flight paths like volcanic confetti nobody asked for. Even smaller eruptions can have ripple effects. Remember that time a volcano in Iceland with a name I won't ever pronounce correctly blew up in 2010? It disrupted all the air travel across the Atlantic, and in our case, a modest ash plume drifting into major air corridors could ground flights across the Middle East, South Asia, and beyond. You know, gas emissions don't respect borders. They drift, mix, and settle wherever the wind decides to drop them. Alright, all this sounds pretty creepy, but with all the modern sensors, scientists should find out about an eruption in advance, right? Not really. As Taftton sits in a really remote region, setting up monitoring stations there is tricky, expensive, and frankly, was never a priority because everyone assumed the volcano was done for. So right now, satellites, not ground instruments, are doing most of the work. Satellites see the big picture, but instruments on the mountain add detail. And that's why it was so important for Taftton to be reclassified from extinct to dormant. Because dormant volcanoes need eyes on them 24/7. When a volcano is labeled extinct, countries don't invest in evacuation plans, hazard maps, or monitoring equipment. Changing Taftton's status forced everyone, from local officials to global scientists, to admit it can cause trouble. And that means preparing for ashfall, gas emissions, sudden eruptions, and the long-term questions. Questions like, what if this awakening isn't temporary? What if this is the beginning of a whole new activity cycle? Long-term, Taftton might settle down again, or it might be entering a period of renewed activity. Volcanoes don't run on human timelines. A short-term phase for a volcano could be days or years, and the uplifting summit might mean there's deeper magma movement, not just a surface burp. It has gone up by about 3.5 inches over 10 months between July 2023 and May 2024. And a mountain rising is like Earth inhaling. And if Earth inhales too deeply, it eventually exhales. And in volcanic terms, that exhale is nothing good. Right now, Taftton is breathing in, and nobody knows when it plans to breathe out. This already sounds like too much drama, but there's more where it came from. Some of the biggest, angriest supervolcanoes on Earth are starting to wake up. When one of these monsters erupts, the whole planet feels it, even people living thousands of miles away. Scientists worry because a super eruption could move faster than our ability to prepare food, evacuate cities, or deal with the chaos afterward. That's what makes supervolcanoes so scary. Not just the explosion, but how little time we might have to react. If you live near Naples, you already know at least one supervolcano and how it acts. Streets crack, steam leaks from the earth, the harbor fills with sediment, and swarms of small earthquakes rattle windows like underground thunder. All of that comes from Campy Flegry, a massive supervolcano caldera that last erupted in 1538. For years, scientists read these signals as classic warnings of magma rising. But two recent studies, one in 2023 and another in 2025, completely changed how we understand what's really going on. And surprisingly, they brought a bit of hope with the danger. In 2023, studies zoomed in on carbon dioxide, a gas volcanoes pump out when magma starts acting up. At Campy Flegry, CO2 levels jumped after 2005 to about 4,000 to 5,000 tons a day, which sounds like magma rising fast. But when scientists checked other gases like nitrogen and helium, the chemistry didn't fit that idea at all. It turned out that the extra CO2 came not from rising magma, but from super hot fluids underground, cooking the surrounding rocks and releasing gas on their own. In the 2025 study, lab experiments showed that the shaking comes mainly from a sealed underground water and steam reservoir. When that natural lid traps pressure, it eventually cracks and releases steam and sets off sudden quakes that people feel at the surface. That idea also explains something that always confused scientists. The earthquakes usually start close to the surface and then move deeper, which is the opposite of what rising magma would do. After the strongest shaking, the ground often sinks a little, like a balloon slowly deflating after you let some air out. None of this means Campy Flegry is suddenly safe though. Magma still sits deep underground and steam-driven explosions can still blast out rocks, ash, and scorching gas without any lava warning you first. What's really changed is how scientists think about the danger. Just watching and waiting isn't enough anymore. If humanity only had 12 months of warning before a supervolcano eruption, we'd struggle badly. Stockpiling food, relocating people, keeping supply chains alive. It would all feel almost impossible. But don't freak out yet, because supervolcano eruptions are extremely rare. The last one happened about 26,500 years ago in New Zealand. On average, scientists think a super eruption happens roughly once every 100,000 years, but Earth doesn't follow neat schedules like a calendar. Sometimes these eruptions cluster closer together, and then the planet stays quiet for a long time. Two massive super eruptions shook the planet within the last 100,000 years. About 74,000 years ago, Indonesia's Toba volcano blew up with such force that it blasted ash across Asia, lowered the temperatures around the world, and may have pushed early humans to the brink of extinction. Then, around 26,500 years ago, New Zealand's Taupo volcano unleashed an eruption, covering huge areas in ash and reshaping the landscape we see today. There's always a chance another super eruption could arrive earlier than we expect. That uncertainty is what keeps scientists awake at night.
Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and it's called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down. And not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, it may be too late for that, but I'll try. The ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy, so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge, and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland show that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, the result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please. Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a supereruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campy Flegry, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campy Flegry erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campy Flegry has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campy Flegry is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super-hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news, because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817, as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of supereruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 supereruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a supereruption. In Bolivia, the Jutirancu volcano is also acting up. It's part of a group of volcanoes that have caused supereruptions in the past. Since the 1960s, the ground around Jutirancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a supereruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a supereruption could happen sometime in the future, and when it does, we'll need to be prepared.
Although it looks perfectly doable, there's still no bridge connecting Great Britain and Ireland. There are a whole bunch of reasons that prevent engineers from starting the construction. One of them is way darker than budgets or bad weather. It's a reason most people never even hear about, and we'll get to it in a moment. So, the first reason why there is still no bridge in one of the most logical positions is geography. The most direct route would run from Scotland to Northern Ireland across the North Channel, the narrowest stretch between the islands. On a flat map, it looks manageable. In reality, that channel behaves like a pressure valve between the Atlantic Ocean and the Irish Sea. Storm systems sweep in straight from the Atlantic with almost nothing to slow them down. In winter, winds roar across the water at speeds strong enough to shut down major bridges. Engineers can't plan around calm days and light breezes. They have to prepare for the worst storm that might hit once in a century. And in this stretch of water, that worst-case scenario looks brutal. Towering waves, violent gusts, and conditions that test even the toughest marine structures. Another problem is that parts of the North Channel drop hundreds of feet, and the seabed has no smooth, level surface ready for construction. It falls away into jagged rock, sharp ridges, and deep trenches. A long span bridge needs solid foundations. Crews would have to drill and anchor enormous pylons into hard rock beneath rough, moving water and juggle strong currents and short weather windows at the same time. Offshore oil platforms survive harsh seas, but they stay fixed in one place and don't have traffic constantly moving on them. A 20-mile bridge moving cars and trains every minute would have to look like a chain of massive offshore towers linked together across one of Europe's most unpredictable marine corridors. Then comes Beaufort's Dyke, the most sinister reason that pushes the idea from extremely difficult to almost reckless. This deep underwater trench lies between Scotland and Northern Ireland. After the dramatic events of the 20th century, UK authorities dumped enormous amounts of surplus munitions there, possibly more than 1 million tons. Any construction team would first need to survey the entire area, map every hazard, and decide whether to remove or avoid them. One mistake could damage the environment or trigger a detonation. Before workers could place a single pier in the water, they would have to arrange a cleanup operation so massive that it would be one of the largest hazardous waste projects ever. Now, add money to the equation. When the officials did some math, they figured out it would cost between $272 billion and $455 billion to build either a bridge or a tunnel here. For perspective, that rivals the GDP of some smaller countries. It could fund entire national rail overhauls, renewable energy transformations, or decades of healthcare investment. Countries don't spend that kind of money unless they know they'll get some economic return, and it doesn't look like traffic demand here will cover the expense. The volume of people and goods traveling between Scotland and Northern Ireland simply doesn't match crossings like the English Channel between Britain and France. Alright, fine, forget the bridge, but why not dig a tunnel? They don't depend on wind conditions, but not everything is so simple here either. An Irish Sea tunnel would cost almost $300 billion and take around 30 years to complete. It would be way longer and more complex than the Channel Tunnel, and become the longest undersea rail tunnel ever built. Crews would drill under deep water, through complex geology, and beneath a seabed contaminated with munitions. Engineers would also have to face a technical problem with rail gauge. Great Britain uses the standard gauge of 4 feet 8.5 inches, and Ireland has a broader gauge of 5 feet 3 inches. That means trains from one network cannot simply roll onto the other. A fixed rail tunnel would need new infrastructure, dual gauge systems, or major upgrades across both islands. So the tunnel wouldn't just connect two coasts, it would mean massive rail reconstruction inland. Costs would balloon even further. The weather would keep causing trouble long after the final bolt went in. Powerful crosswinds would sweep across a high bridge and force traffic to stop without warning. Salt water would eat away at exposed steel every single day. Crews would have to face corrosion, replace parts, and secure loose elements while Atlantic storms pounded the structure year-round. This would never become a structure you build and forget. It would demand attention every week of its life. If you think, but the Channel Tunnel is managing somehow, remember it runs beneath far calmer waters and avoids direct exposure to wind and waves. The North Channel gives no such protection. And at the same time, transport across the region already works well. Ferries cross the Irish Sea in a matter of hours. Airlines run frequent routes between Belfast, Dublin, Glasgow, and London. You can find affordable tickets and reach your destination quickly. The current network moves people and goods efficiently. This pattern repeats in other places as well. Let's move south toward the Strait of Gibraltar, where Europe almost touches Africa. At its narrowest, the strait is just about 9 miles across. And that sounds temptingly short, but the currents rip through that narrow gap between Spain and Morocco with some of the strongest forces you'll find anywhere on Earth. And as if that weren't enough, that stretch of water sits right on the seam where the African tectonic plate and the Eurasian tectonic plate press against each other. The African plate inches north every year, only a couple of inches annually, which sounds harmless unless you remember that continents weigh trillions of tons. When those plates grind, they stick, strain, and then snap. That snap sends out earthquakes, fractures the seabed, and shifts the ocean floor without warning. Even if engineers somehow anchored a bridge across it, the currents would hammer the structure day and night, shaking bolts loose and stressing every joint unless designers overbuilt it to an extreme degree. When you look at the depth, the challenge drops, literally, to another level. Parts of the strait plunge close to 3,000 feet, taller than many skyscrapers. Any support columns, known as piles, would need to stretch almost half a mile downward, drilled and secured into unstable seabed rock. Engineers would probably have to assemble them in enormous reinforced sections and bolt them together like pieces of a steel spine. And after installation, the structure would still face earthquakes capable of snapping rigid supports like dry twigs. Plus, the strait functions like a giant breathing valve between the Atlantic Ocean and the Mediterranean Sea. The water entering the Atlantic carries lower salinity, and the Mediterranean water contains more salt, and therefore weighs more. Two-layer exchange creates powerful vertical mixing, swirling eddies, and turbulence zones that look almost like underwater storms. All that turbulence lifts nutrients from the deep and feeds phytoplankton. Blasting, drilling, or dumping construction materials into that environment would hurt phytoplankton and the entire sea food chain. Because of all of that, a tunnel here sounds like a smarter alternative. It took engineers roughly 2 decades of research and planning, and now construction is supposed to start here around 2030, with about 10 years of work before trains could realistically run beneath the strait. Even then, builders will fight pressure, heat, rock density, and the constant reality that 2 continents continue nudging toward each other inch by inch beneath their feet. The tunnel is supposed to plunge down to more than 1,000 feet below sea level at its deepest point. It would stretch close to 25 miles, with roughly 17 miles running directly beneath the seabed. If it does work out, high-speed trains could carry passengers and freight from Spain to Morocco in about 30 minutes. And that's not just convenience. That's a rewiring of trade routes, labor movement, and tourism, and economic gravity between continents. More than 12 million people could travel on that route every year, so the tunnel will really be life-changing. If we zoom in on Greenland from space, it looks white and calm. But deep beneath its surface, something may be moving. For years, radar scans have been showing strange plume-like distortions that couldn't be explained. Something is bending the ice from within and pushing it upward. And now, scientists finally understand what it is. Greenland is the largest island on Earth, roughly the size of the entire American Southwest. Over 80% of it sits under an ice sheet up to 10,000 feet thick. If that melts, sea levels will rise 24 feet, which in short means goodbye Florida coastlines. What's really cool is that under those 2 miles of ice lies an entirely hidden landscape. There are mountains under it, whole ridgelines sealed in. There's even a massive canyon stretching about 460 miles long. That's longer than the Grand Canyon. It was discovered only in 2013 using ice-penetrating radar. We're talking about a network of canyons untouched by sunlight for millions of years. It's the only place on Earth like this. That same radar also shows the ice's internal layers. Think of them as pages, or chapters adding to a book annually. Snow falls at around 12 degrees Fahrenheit and never really melts. It piles up, gets squeezed together, and turns into dense glacial ice. While it's stacking up, it also slowly, very slowly, drifts toward the ocean, thanks to gravity. In the deep interior, that motion is barely noticeable, maybe just a few inches per year. At least this is what scientists expect to see when scanning beneath. But in parts of northern Greenland, the story is different. Those neat layers are not lying flat. Instead, they curve upward. It looks like something deep inside the ice is slowly lifting it from below. So what's actually going on? The new idea is thermal convection inside the ice. It sounds complicated, but the principle is simple. Greenland's surface can drop below negative 40 degrees Fahrenheit, while the base, way down below, can be slightly warmer. Earth leaks heat upward, non-stop, and the pressure from nearly 2 miles of ice lowers the melting point down there. The temperature difference is small, but across that much thickness, even the smallest differences matter. The ice remains solid, yet the deeper layers become easier to deform. Over long stretches of time, that softer ice can rise in slow domes, while colder ice above settles around it, bending the once flat layers into those plume shapes radar picked up. It only happens in certain spots. The ice needs to be thick enough for that slow vertical movement to take place. If it's too thin, there's no space for the loop to form. And if it gets pulled sideways too much, the pattern gets all messed up. And that's why you only see the plumes where Greenland is both huge and pretty calm. But Greenland isn't only changing underneath, it's also experiencing transformations on the surface. Or better said, it opens from above. We're talking about real-life trapdoors in the ice called moulins. Think of them as vertical drain holes right in the middle of the ice sheet. In summer, meltwater doesn't always just trickle off the edge like a lazy river. Sometimes it finds a weak spot, tears it open, and suddenly the entire stream drops out of sight, forming a deep pit. Some moulin openings are tens of feet wide, and the shafts can plunge hundreds of feet straight down. In extreme cases, they can connect almost all the way to the base of the ice sheet. When scientists tried to make the water math add up, it just wouldn't. The only way it worked was if the moulin was way bigger inside than it looks from the top. Like the opening is just a doorway, and underneath there's a whole hidden room carved into the ice. And that detail matters, because a bigger room can store more water. More stored water means more pressure, and more pressure can make the ice slide faster. And here's the biggest part. These shafts are highways from meltwater straight to the base of the ice sheet. Water flowing down there lubricates the ice. All that water acts like grease on a baking pan. It lets the massive glaciers slide way faster into the ocean. Bigger moulins can deliver more water more often, sometimes in sudden surges. This cranks up pressure at the base and even pushes water into cracks, creating weak zones that make the plumbing network even more efficient the next summer. So there are weird plumes, there are moulins, and that's not all. Greenland has a history of straight up losing huge chunks of ice in dramatic crashes called calving. There are records of skyscraper-sized blocks of ice suddenly breaking off a glacier and vanishing into the ocean. In 2015, the Jakobshavn Glacier calved an iceberg the size of Manhattan, and in 2020, the Spalt Glacier collapsed, sending an area of ice bigger than 40 square miles into the sea. These are giant avalanches with chunks cracking, tilting, and tipping over like dominoes before splashing into the ocean. Sometimes the ice flips over entirely as it hits the water, sending a wall of icy spray hundreds of feet into the air. The sound of these crashes is absolutely deafening. It echoes across the water like an endless string of thunderclaps. When a piece of ice the size of a city block hits the ocean, it creates massive waves that can easily swamp nearby boats. Other times, massive slabs float off slowly, like frozen islands drifting away, to eventually break apart into smaller pieces. We know Greenland can lose colossal amounts of ice without a giant disaster. A 1,640-foot thick section called Prudhoe Dome melted completely 7,000 years ago during a normal warming period. Greenland doesn't need to become super hot to lose ice. It just needs to stay warm for a while. Scientists also know that ice can move up from deep inside. Water can cut down through the ice, and the rocks below show that Greenland has lost big ice domes before. Perhaps the best proof, okay, maybe not the best, but certainly the cutest one, that Greenland is going through various changes is the behavior of these creatures. They might look cute to us, but they are actually very dangerous to their prey. Orcas are killer whales. They are black and white torpedo lookalikes with a dorsal fin resembling something that belongs to a Pixar movie villain. The thing is, they hunt in coordinated family groups, and they're actually smart enough to plan. They sit at the very top of the food chain. So what's going on is that orcas don't really like heavy sea ice, not because they're scared, but because it's a trap. Ice can block breathing holes or mess up their hunting, or maybe it just makes it harder to move around. So for a long time, thick ice acted like a natural fence that kept them out of certain areas near Greenland. Now that fence isn't as reliable. As the ocean around Greenland stays open for longer stretches, prey can spread into areas that used to be locked up, and orcas can follow. Animals that usually rely on the ice for a safe hiding spot suddenly find themselves completely exposed. The newly melted water basically turns into an all-you-can-eat buffet for the incoming whales. The bottom line? Orcas are reacting to the new layout. It's like watching a new boss character enter a level that used to be sealed off. The moment you see them cruising around like they own the place, you know something about the environment has already shifted. In the past few decades, Greenland has been losing ice faster than it used to, and all of that ends up in the ocean. So this isn't just a cool mystery about weird radar shapes. Sea level forecasts rely on predicting how ice behaves. If miles-deep ice acts like bubbling putty, hides massive subterranean water rooms, and shifts local wildlife, the old predictions fly out the window. Greenland, is a living system holding enough water to sink Florida, making every new discovery a very big deal.
When you think about it, islands aren't supposed to just, disappear. But that's exactly what happened in the Caspian Sea. NASA satellites watched a brand new island emerge, only to see it vanish completely within a year, like a ghost. And this wasn't a glitch or a mirage. It was real land, formed by a violent mud volcano, then swallowed back into the sea like it never existed. So what's going on here? The ghost tale started in early 2023, off the coast of Azerbaijan. There's this place called the Kumani Bank, a so-called mud volcano in the Caspian Sea, about 15 miles out. It has erupted multiple times, and each time, this led to a fascinating story, the one we're learning about now. When it erupted recently, it spewed a chaotic mix of mud, gas, and rock into the sea. But this time, NASA's satellites were there to catch it all on camera. In November 2022, the volcano's peak was still hidden beneath the waves. Just 4 months later, a brand new island appeared, stretching about 1,300 feet across. And then, in December 2024, it was gone, completely erased from the map. NASA said it had retreated from view like an apparition. The same thing happened in 1861, 1950, and several times since. But how does it work? Well, most people think of volcanoes as fiery mountains that spew molten lava. But mud volcanoes, like the Kumani Bank, are a completely different kind. They don't erupt with lava. Instead, they blast out thick, bubbling mud, sometimes mixed with methane gas, and that's a stinker. Scientists have found over 1,100 of them on land and shallow water, and there may be over 10,000 more hiding deep in the ocean. Now, these things are strange, dangerous, and still barely understood, and Azerbaijan is just a goldmine for them. Over 300 mud volcanoes have been counted on land and offshore, more than anywhere else on Earth. So, why so many? Because the Arabian and Eurasian tectonic plates collide under Azerbaijan, pushing against each other. This creates crazy pressure. Deep underground, water gets heated, but instead of melting rock, it mixes with minerals to create thick, pressurized mud. Tectonic forces squeeze this mud upward through faults and cracks in the Earth's crust. And when the pressure becomes too much, well, boom, it suddenly bursts, blasting mud, rock, and gas into the air. And sometimes these eruptions create temporary islands, like the one NASA just saw. But there's another crazy part. Mud volcanoes aren't just messy, they can be terrifyingly dangerous. Some mud volcanoes are small puddles just a few feet across. But others? Well, they're absolute monsters. The tallest known mud volcano is about 2,300 feet high, nearly as tall as the Burj Khalifa skyscraper. The widest one is 6 miles across, big enough to swallow an entire city. Which brings us to the weirdest part. In some cases, they don't just spew mud, they ignite, sending massive fireballs into the sky. A horrible fountain of mud, gas, and flames towering hundreds of feet high. One of those happened in 2001, and it burned for days. That's why they often lead to horrifying catastrophes. In 2006, there was the Lucy mud volcano disaster in Indonesia. It erupted out of nowhere in the middle of a populated area. And what's even crazier, the mud flow never stopped. It's still erupting today. It buried tons of villages under the mud. Over 24,000 people lost their homes, and scientists predicted that this horror would continue for 20 more years. At first, no one knew what caused it. Some think it was just an earthquake 2 days later. Others blame drilling operations nearby. A gas company was exploring right before the eruption happened. Well, whatever the reason, it has turned entire towns into ghostly wastelands. And they're not just dangerous for us. They're a disaster to the planet in general. They just love to leak greenhouse gases. They constantly leak methane, one of the most powerful gases that warms up our entire planet. These guys release between 30 and 140 million tons of methane per year. That's up to 9% of all natural methane emissions, and more than some entire countries produce. Well, that's the estimate at least. Since most mud volcanoes are deep underwater, we still don't know how much gas is escaping into the ocean and the atmosphere. Many of them lie on continental slopes, too. That means they're holding huge amounts of trapped methane. If they suddenly decide to go wild, that won't be good for anyone. Some past eruptions in Azerbaijan have been insane as well. A few mud volcanoes there blasted flames so high that pilots could see them from airplanes. On July 4, 2021, a mud volcano on Dashley Island erupted like a true monster. The flames shot up 1,600 feet into the sky. That's taller than the Empire State Building. The fireball was visible from miles away. Even the capital of the country, Baku, saw it light up the night sky. Luckily, no oil platforms nearby were damaged, but it really scared people for a moment. Another one, also near Baku, erupted in 2018 so massively it shook the ground for miles. Luckily, the Kumani Bank isn't such a monster, well, compared to those other examples. In 1950, the Kumani Bank erupted again, creating a horrifying pillar of fire about 330 feet high. It burned for 15 minutes. This created a large oval island as well, and it disappeared just about half a year later. Then another powerful disaster took place in 1959. For almost 20 minutes, flame reached the heights of about 650 feet, like about 2 statues of Liberty, including the base. The eruption brought up breccia, a type of rock made of broken fragments, and this time, a newly formed island lasted for 3 more years before eroding away. The thing is, those islands are never built to last. Mud volcano islands aren't made of solid rock, they're fragile piles of sediment. The Caspian Sea's waves and currents slowly eat away at them, washing it back into the ocean bit by bit. NASA isn't sure if the 2023 Kumani Bank eruption was as fire as that, but it didn't last that long either. All that remained was a faint shadow of land, barely peeking above the water. But will it rise again? Well, probably. Just don't get too excited. The Caspian Sea might create more ghost islands in the future, only to erase them again, as if they never existed. Now, interestingly, not all mud volcanoes are disasters waiting to happen. Some are actually ancient holy sites. Deep in Balochistan, Pakistan, stands Chandragupta, a sacred, constantly bubbling mud volcano. Hindu pilgrims believe it's a gateway to the deities. They visit it as part of their journey to the nearby temple. Before entering the temple, they tossed offerings into the mud pool, coconuts, rice, and sometimes even money. This volcano seems safe. People prayed to it for centuries. It never erupts, just slowly breathes like a living being. But even though it's sacred, it's still dangerous. The land around it is unstable, and eruptions can happen without warning. What's even crazier is that we might not be alone in having these bizarre formations. Scientists think that Mars may have mud volcanoes too. NASA has recently spotted strange dome-like creatures on the red planet. That could be ancient Martian mud volcanoes. And if that's the case, that's just another clue into an entire pile of evidence that Mars used to have liquid water. If they investigate it, they might even find some signs of life there. Well, maybe. They also think that Europa, Jupiter's icy moon, might have a version of these guys, except instead of mud, they erupt slushy water and ice. Now, the worst part about those guys is that we still don't fully understand them. Scientists can't predict how much methane they really release, why some of them erupt while others continue to sleep, and what they can tell us about life on other planets. We barely scratched the surface, literally. The deepest mud volcanoes are thousands of feet under the ocean. That's why many of them are completely unstudied right now. But perhaps they'll tell us their stories one day.
This glacier in West Antarctica is called the Doomsday Glacier, and that's not clickbait. If it collapses, we will all feel it. Right now, scientists are doing their best to understand what's happening underneath it, because once this glacier goes, we won't be able to stop this catastrophic process. Its name is actually Thwaites, and it's an almost 80-mile wide formation. So what will happen if it collapses? Huge chunks of ice will start snapping off and crashing into the ocean. That will push sea levels higher, and fast. Then things will get even worse. When ice disappears too quickly, it can trigger sudden flooding along nearby coastlines. In extreme cases, it can even create local tsunami-like waves, more than enough to cause serious damage. And it'll be just the beginning. If Thwaites gives way completely, it will raise global sea levels. Cities like Bangkok, Manila, parts of the Netherlands, and entire islands will start disappearing underwater. Millions of people will have to move. But dumping so much fresh water into the ocean can mess with currents, change temperatures all over the world, and impact weather patterns far from Antarctica. Seasons might stop behaving the way they used to. And the worst part is that once this chain reaction starts, it's likely to be irreversible. That's why scientists are watching Thwaites so closely right now. To figure out how this could fall apart, researchers started analyzing the cracks in giant ice shelves. Think of these shelves like massive floating platforms of ice. They sit on the ocean, but they're still attached to land, like a door that only stays in place thanks to its hinges. As long as the shelf stays intact, it slows the glacier behind it. But if cracks spread and the shelf breaks, the glacier basically loses its brake and starts sliding into the ocean way faster. Using tons of NASA satellite images, scientists examined deep vertical cracks in Antarctica's ice sheet. This is the biggest block of ice on Earth. It's already losing about 136 billion tons of ice every year. They zoomed in on one especially fragile spot, the Thwaites ice shelf sticking out from the Thwaites Glacier in West Antarctica. Right now, the ice shelf in front of Thwaites works like a cork in a bottle. It slows everything down, but if that cork pops out, it'll kick off a chain reaction. Interestingly, the way these cracks form turned out to be way more complicated than we used to think. Older models supposed that ice broke in predictable ways, like snapping a clean piece of glass. In reality, it behaves more like a windshield full of tiny fractures. They're spreading in odd directions and changing over time. That's why the team worked out a new approach to studying the cracks. The Thwaites ice shelf is super shaky right now. It changes fast, and it's full of cracks. Plus, the ice there is moving more quickly than it should. And since this shelf is the last thing holding the rest of the glacier together, it's not a great sign. It's like a cracked dam. While it's standing, it slows the water behind it. But once it breaks, nothing will be able to stop the rush. The problem is, ice shelves don't mend themselves. Once a big chunk breaks off, it's gone for good. That's why researchers are so focused on spotting the warning signs before the break happens. The goal is to figure out exactly when an ice shelf is getting close to failing. To do that, the team used NASA's IceSat-2 satellite, which was scanning Antarctica from space between 2018 and 2024. This satellite is incredibly precise. It can measure tiny changes in ice height and track how the surface shifts over time. Using that data, the researchers created a new way to slice through the ice digitally. It lets them see detailed cross-sections of cracks, almost like X-rays of the ice shelf. Now, they can observe how different types of fractures grow, spread, and connect. That's how they found out that the eastern side of the Thwaites ice shelf looked much more broken up, while the western side seemed pretty stable. Scientists aren't sure why yet, but it might be due to warmer winters, less sea ice protecting the shelf, and changing ocean currents flowing underneath it. This new work was based on an earlier study from 2023. It looked at the Larsen B ice shelf, which completely collapsed back in 2002. That shelf was huge, about 1,250 square miles, roughly the size of Rhode Island. After years of weakening from warmer air and ocean water, it shattered in just 5 weeks. At that time, no one saw it coming, even though the warning signs were there. Now things are different. With the new research method, we have much better tools to spot trouble early and figure out where cracks are likely to spread next. The team also gathered satellite data from more than 40 ice shelves across Antarctica. It's like building a gigantic map of cracks across the continent. Now, this dataset includes detailed 3D information showing where fractures are and how deep they go. That's the kind of data scientists have been missing previously. The big ice sheets in Greenland and Antarctica are super sensitive to warming temperatures. As the planet heats up, huge parts of these ice sheets could suddenly collapse. Researchers have identified 3 main ways this could happen. First, the ice could slide. In some places, the ground under the ice slopes downward as you move inland. Warm ocean water might eat away at the ice from below, and then the ice will start sliding faster into the sea. The floating ice shelves out front are supposed to slow things down, but they're often too weak to help. The second way is linked to ice cliffs. When an ice shelf breaks apart, it leaves behind a tall wall of ice, like a giant frozen cliff. If that cliff gets taller than about a 30-story building, it can't support its own weight. Meltwater seeps into cracks, pries them open, and big chunks start to collapse. That collapse leads to even taller cliffs, which can also fail. It's basically another chain reaction. And the third way is the melting on top problem. As ice melts, the surface gets lower. Lower ice sits in warmer air. Warmer air causes even more melting. That's a vicious circle that keeps speeding things up. West Antarctica is one of the biggest trouble spots. After all, it's home to fast-moving glaciers like Pine Island and Thwaites. Satellites show that these glaciers are thinning, retreating, and flowing faster into the ocean. These are clear signs that the first problem, the sliding one, may already be happening. And sadly, according to computer models, this retreat won't stop anytime soon. In Greenland, the biggest concern is surface melting. Over the past decade, melting on top of the ice has increased a lot. These days, it's the main reason why Greenland is losing ice. In a worst-case scenario, especially in West Antarctica, some models suggest that huge ice loss could happen in less than 300 years. That means by the year 2300, sea levels could already be much higher than expected and coastal flooding would be far more common around the world. Right now, the latest reports say sea levels could rise anywhere from 1 foot to over 5 feet by 2100. Satellites already show that parts of Greenland and Antarctica are thinning and flowing faster than they used to. Computer models help test what might happen next. What if these changes could feed on themselves and speed up ice loss even more? So, right now, researchers from all over the world are working together to figure out how close these ice sheets are to tipping points. There's still a lot we don't know. Some models suggest certain ice failures might not be as dramatic as we fear. Others say the risks are very real. That's why understanding this better matters so much. The clearer the picture gets, the better chance we have to reduce future damage and avoid constant coastal flooding. More powerful